automated document feeder. Metallics is tasked with the project of digitizing fingerprint cards for various legal departments and the FBI and police departments, etc. So one of the key issues with this is how to interface with the paper. You can't use typical document feeder systems. So the process that we go through is actually picking and placing this with a Cartesian robot. We use a Bernoulli cup, which uses the Bernoulli principle, works just like an airplane wing. So it creates a vacuum of air above the paper, or a low pressure area above the paper, and causes lift on the paper to pick it up. And we have to accurately be able to place it on a scan bed, and align the paper, and cover it with a backplating, and run it through a scan process that's then processed by software that Metallics owns and operates. So some of the key features that we needed to look into when we were developing this was they actually have a current model that was developed by a previous senior design team. And one of the issues that they had was the compressors can be quite loud. So one of the key features we had to go for in this project was quieting that process. One of the ways that we were able to do that was to use an oiled compressor, and that can operate down to, it actually says that it can operate below 65 dB, but we've measured it much, much lower than that. It operates somewhere in the 40 dB range. So actually operates fairly quietly. One of the other things we needed to focus on was gaining a more controlled and rigid path in the structure. The previous one was an arm robot, and so sometimes when we pick things up, it's not very controlled. So going with the Cartesian process, we're able to very rigidly control where we place the paper. One of the key features we wanted to work on, though, was the alignment of the paper, because sometimes when it picks it up, it may not know the orientation or the exact placement of where to put the paper. So we need to be able to corner crowd this into the scanner so that you don't get bleed through and some issues with scanning the paper. So developed a slide tool that actually slides out over the paper, and it does two things. It covers it for backplating so there's not bleed through, but also there's an alignment brush that lowers and pushes the paper into the corner crowd. And so on the EE side of things, some of the things that we worked on were actually developing a board. Last semester we prototyped a lot of this stuff on Arduino, and this semester we really worked on moving this towards our own controller. So we integrated motor control systems, and we integrated all of the processing and everything like that, and we voltage regulation, overcurrent protection, all that stuff onto our own boards this semester. And routing things, temperature control, we also integrated temperature control. And also it was a lot of systems and controls work on this. So there's a lot of stuff where when you pick things up, you need to determine whether or not the paper is actually attached before you try to move on to the next process. And there's a lot of stuff where you're actually trying to analyze a lot of information to do that stuff. So there's a lot of system control work on that. Some of the key issues we ran into with this project this semester was actually was kind of hand of God things. So a couple of weeks ago, we actually had a major power outage, and so some of the components we were having 3D printed, the printer stopped working. We had to reprint those. And additionally, one of the power supplies we had failed, and the overcurrent protection on it failed. And so we had a lot of power going through our system and fry about 80% of our components. So we've spent the last 2 weeks completely rebuilding the project. And what you see here is what we have done in the last 2 weeks, basically, is we've rebuilt the project. So that's one of the biggest issues that we've had with the project so far. But we actually have successfully implemented it and got it working. So it's a proud moment for us. I'd like to open up the floor for any questions, if anybody has anything to ask.
What do you mean by is the Cartesian process?
The Cartesian robot? So you have like two systems. It uses XYZ robots that work in that plane. They're Cartesian robots. So you have robots that are arm-based robots, and they can move in any direction. And Cartesian robots are fixed in their path, so they move along a specific plane.
And so you said that before you had something else, and this was much better than.
Yes, the robot they had before was an arm-based robot. So it's just not it's not rigid in control.
I'm thinking that.
Oh, yeah. Okay. Yeah, any other questions? So working on a split team is always a challenge, especially when you're trying to convey certain information. So a lot of times you get used to the people you're around and you have a basic level of expectations of what they're going to understand when you're going to explain things. So a lot of times when you're trying to break things down and explain why something has to work a certain way or why, that won't work a certain way, it's frustrating. You have to step back and remind yourself that they haven't had the same experiences as you. So you have to